Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. In today's video, we are going to look into dependency of Earth's energy budget on latitude. In the last video, we looked into average global mean Earth's energy budget, but clearly tropical regions are warmer than polar regions. And clearly, tropical regions receive more energy from the sun than the polar regions. So in today's video, we are going to look into that distribution of energy across latitudes. This is very simple video. So if x-axis is latitudes, and we start from equator, which is 0 degrees, and let us put here 90 degrees south, namely South Pole, and we put here 90 degrees north, namely North Pole. And then here we have different latitudes of the southern hemisphere and different latitudes of the northern hemisphere. And if we put on the y-axis energy received or radiated in 1 year on average, then we can construct this graph where with red, I will indicate the amount of energy that the Earth receives from the sun on an annual average basis. So let us qualitatively indicate that like so. So clearly, most of the energy is received at the equator, which is not very clear in my graph. So let's do it again. Now this is better. So most of the energy is received in tropical regions, and less energy from the sun is received at the north and south poles. Now, how about the amount of energy that the Earth sends back into the space? If we indicate that with the blue, then that curve looks like this. So what can we conclude here? We can conclude that in high latitudes, namely here, as well as here, as you can see, this figure is not to scale, but I don't want, whenever possible, I don't want to use pre-prepared figures because I want you to see how I plot it so that you know what is the order of plotting and how you should plot it. If I show here, I noticed that in teaching, if I show here a nice curve, quite often people don't know where you should start plotting it and they try to memorize lines. The goal is not to memorize lines, but to know the concepts. And the concept is that high latitudes lose more energy than what they receive from the sun. So here we would say we have deficit of energy. But over here in the tropical and subtropical regions, we receive more energy from the sun than what we give away. So we would say that we have surplus or sufficit of energy. So you can see in terms of Earth's energy budget, we can locally have sufficit. That never happens in terms of governments and their budget. There is always deficit. But in the atmosphere, there is sufficit, there is deficit. You will also notice that there are two latitudes, this one over here and this one over here, where the amount of energy that we receive from the sun equals the amount of energy that the Earth sends into the cosmos. And these two latitudes sit at 38 degrees north and 38 degrees south. So, for example, I am located in Montreal, Canada. Montreal has latitude of 45.5 degrees, let's say 45 degrees. which means here in Montreal we emit more energy than what we receive from the sun. I would also like to discuss why does this blue curve has this paraboloid shape. Because perhaps you might think why this curve is not constant everywhere. Why is Earth not emitting the same amount of energy across all latitudes? Pause the video for a few seconds and think about it. What law from previous lectures governs the shape of this curve? The answer is Stefan Boltzmann's law. You know that Stefan Boltzmann's law goes that energy radiated is equal Stefan Boltzmann constant time temperature to power 4. Stefan Boltzmann constant 5.67 times 10 to negative 8 watt per square meter per Kelvin to power 4. So if the temperature is high, energy that is emitted is high. But temperature in tropical regions is higher than temperature in polar regions, so the amount of energy that Earth radiates into the space from the tropical region is consequently higher than the amount of energy that we radiate from polar regions, because polar regions are cold, and this relationship holds. Okay, so the last thing to discuss here, if we now say, okay, this is equator, how is it that the tropical regions do not get infinitely warm and the polar regions do not get infinitely cold? Because over time, if you have surplus and you have deficit, you will have warming and cooling respectively. The answer is there is transfer of heat from low latitudes to high latitudes. Every day, every season, constantly there is transport of energy from surplus regions, from tropical regions, to deficit regions, to polar or high latitude regions. And this transfer of energy comes through two processes. First is the general circulation of the atmosphere, various wind and weather patterns that are basically serve constantly to transport energy from low to high latitudes. Fundamentally, all weather on this planet happens because the planet attempts to transfer energy from warm regions to cold regions. And that goes through general circulation of the atmosphere. Now, within general circulation of the atmosphere that we will discuss in details later, there are various smaller scale weather systems, but nevertheless, all that serves to transport energy from tropics to high latitudes. That's first process. The second process is ocean currents. Ocean currents also transport energy from south to north, from low latitudes to high latitudes. Keep in mind that the amount of heat stored in the ocean is much, much larger than in the atmosphere. Approximately 1,000 times more energy is stored in the ocean than in the atmosphere. But ocean currents are very slow, and sometimes it takes decades, even centuries, even some research suggests thousands of years for ocean currents, particularly deep ocean currents, to adjust to different conditions. Whereas general circulation of the atmosphere and wind systems perhaps transport a smaller amount of heat, but they transport it much, much faster and more rapidly than ocean currents. We will discuss in future videos in details both ocean currents and general circulation of the atmosphere. In today's video, we continued the concept of Earth's energy budget, but we did not look into average global Earth's energy budget, but Earth's energy budget as a function of latitude. In the next video, we are going to look into daily Earth's energy budget, which is a rather complicated topic, but we will scratch the surface and you will have a nice insight into that beautiful process. Until then, goodbye.